So today we're gonna assemble a sleigh, which seems to basically be some kind of tag, which we want to do some sort of sort on. So let's see if we can read that in. I'm gonna try and use Python today. And I've already saved the input over there. I haven't used Python for a while, so I'm just going to do some. Okay, I'm reading that. Is there a trim strip? Okay. Is there a split? Okay. So we basically want this underscore. We want something, not that, not that, not that, not that, not that, something, not that, not that. Is that a thing? Didn't explode, but. I already miss GoFumt. You mean I need to put in my own spaces? So let's see if we can swap places. This is the input. It's very rigid. The data is just dash and dash. So how do we represent this? I suppose we can do a tuple. So you can go from A to B. A to B. What's this? And that would be 0, 1, 2, 3, 4, 5, 6, 7. Never mind. That's good enough for input. Okay, can also do for. I'm wondering if I can do this as a comprehension. But I basically need to. Let's see if we can look up the syntax for that. I haven't used Python for quite a while. Really? Do they not call it? For X in, yes, so I could do for line in, but then what do I do with line? I need to work on the line in that as well. For X in, for Y in, if. So that's a double loop. But I don't necessarily need to loop that, I just need to make an assignment. Okay, let's not deal with that now. Let's just use what we got. So we have We have order be a watch. Let's just have that be a set. Can then order dot append. Sure. We have some type of order, and we basically want what do we want? We cannot sort it though, so this reads P before O. Let's do the sample input. C before A, C before F, A before B, A before D. So basically, if we do C, we find everything that depends on C and unlocks that, whatever that means. I think that is probably represented as a graph quite nicely. Okay, so let's do this. We have that. Is that a thing? Let's do a list. Append. I'm just gonna do that manually. While and then we basically need to have the frontier be sorted. We need to remove that. Then we need to find all for A, B in order if A equals X, and then we unlock B, and then we basically frontier extend. Does that compute? That does compute, and we want to we do that. We do front X. A, B, D, E, E. That's not right. So we can't just do A, we need to find. So let's find everything that is not. Okay, let's find everything and then remove all that stuff that's there. So frontier, let's have it be. filter. So X for X in. Read the input. We want every letter in the frontier that is not in the left position. Can we do A, B, 4? So there we have everything, and then we subtract everything that is ever dependent on anything. But why even do that like that? Can we do a, is it the other way around? Cab DF, D is an extra E there. If A and X cab def. I got the order wrong of the last two. So A is everything that must be finished. And then we remove everything that has a precedent step. And that's the task that we are free to choose from. Here we keep track of the order that we traverse things. Here we take the alphabetically first one in the available ones. Then we remove that from the frontier. And then we find everything that it's unlocked by doing that. Meaning that we unlock that, but we also need to make sure that it can have several dependencies, right? So either B in the order if we have the key and B has not already been visited, and we need to check that it's not locked also. How do I do that? Let's not do that like that. Let's do that as a dictionary instead. And then have... Oh, does that work? Doesn't that mean that the key has to be unique? Never mind. And can we open up a so X be a list of C, B, and then we have X. And what can we do with that? To dict suddenly dict of X. What if we can have several C's, and we can have several 2B's. Yeah, so that doesn't work. Unlocks. Okay. And then we do first item. I do have some memory of that being a thing. Operator item getter item. Map that onto the order. And then not get cab def. Okay, blah 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 blah. Okay, unlock B. The issue was that B could still be locked by some other A. Right? So I need to find... Okay, I need to find all the keys that are locked by that. Okay, so... For... There we have every ace that we think we did unlock. But then we need to find... Blob, blob, blob. Potential unlocks if they are not locked by something else. Locked by... Okay. A, B in order where B equals in unlocks. And we want all the B's. And that the key isn't our key. Where? I think I mean if. Locked by. I think I got them the wrong way around. So these are the keys needed that are not in that. I don't think I need that. Locked by. And then this is basically if locked by. I'm gonna check the length of that. If that is 0, then we can do that. Okay, let's see if I remember how we did this. X unlocks locks, but still locks them. Okay, so C unlocks A and F, correct? And nothing still locks them. Cool. And then A unlocks B and D, and nothing still locks them. And then if we do B, is that going to E? B unlocks E, but D and F still locks them, right? D, so we cannot add E to the frontier. And then C, A, we should put those on the frontier A, F, B, D. Why does it stop after a C and A? So we do C, A, B. And then we do D. And then we do F. Oh, but those have been unlocked. I need to mark that. Do I remove them from the order? Okay. And that for A and A not been traversed, meaning that we have not already unlocked this. In order B locked by A. If B is unlocked and A is not the key that we just did, and A is not already in traversed. Okay, we should do that either way. Should always do that. Cab DFE, yes. Yes. Let's try that on our input. That's suspiciously short. But the frontier must be empty, right? Here we unlock every node B. If we now have the key, we haven't already been there. And then we check that it doesn't have any other locks on it. And then if it doesn't have any other locks on it, we unlock them by putting them in the frontier. And then we mark X as traversed. So what went wrong on that input? Oh. Starting with frontiers, so those are the ones that are unblocked. MHPW. We do HMPW. And then we do print. We never unlocks anything. Then we do else. And unlocks still locked by. So these are the ones that we could have unlocked, but they are still locked by those. Let's just do the stupid thing and make sure that, yeah. I didn't expect that to be correct, but just making sure. a little bit more compact. Unlocking H, and H is a requirement for all of those, but they still require all of those. Then we unlock that. But those two are still locked by those, and then we do the first of that. But those are still locked by those. And then we stop. Which must mean that the frontier is If I were on my Linux system, I'd probably just do a quick dotty graph of this, just to visualize it, which would help to know what's going on. But I'm on my Windows and I don't really know how to do that easily here. Okay. Find everything. X. Let's call it key instead. And that's the same information that we already print. Let's do a little helper def. Just arbitrary stuff. Let's call them steps. And then we basically return steps, but we also join them. Unlocks. Set of unlocks. Locked by. Starting with frontier, cool. That's funny. What if that function works on the set? Does not. Ah, because the frontier is empty. Unlocking, yes. Frontier is whatever remains, yes. And we cannot add anything to the frontier because they are still locked. I wonder if my initial frontier is faulty somehow. So here, right? We find every step A. We don't care about B in that case. And then we remove that step because it had some prerequisite. Cab DFE. And if you trace that through, we have C because it doesn't have any prerequisites. Unlocking C. And C didn't unlock anything? What? Ah, okay. Using key. Using C, unlocking AF. Frontier is AF. Using A, unlocking BD. Frontier is BDF. And then using B, would have unlocked E, but it's still locked by DF. Frontier is DF. Using D, is still locked by F. Frontier is F. Using F, unlocking E. Frontier is E. Using E, unlocking nothing. Frontier is nothing. That's how I expect it to work, but then my input doesn't do that. How many? That is what? How many lines is that? 101. That's okay. Using H. H is the prerequisite for all of those, but those together are locked by these. Not that everyone is locked by everything in here, but this set is locked by keys from that. Could it be that I forget other stuff? No, because then I would be locked by them and found again. Alright. But where did Q go from? Okay, Q is not locked by P. So if we do so there we have everything. Okay. But then we also have every A for A, B in order if B in the B's above. And that's basically what I have, right? I mean, that should never happen, right? B should never be traversed because B was locked by this. Right? Right? It's here we need a dash. Five steps that the key was blocking. Figure all those. Each of those steps are still blocked by some other step. So these will be the keys that we still need. Yeah, so these are the ones that we would unlock. Because they are not, yeah, but not if they're just locked by this key. So they are not locked by the key we just locked. I think I need to do this by, I need to do this for each, right? I can't just go through, okay, yeah. I think I need to, so 4-step in unlocks. Okay. For A, B, if B equals step, and A is not the key, and A is not in traversed, and then we can say any. So blocked, if not blocked, then we run here dot add step. Does that add the step? Yeah, I think the issue was that I was treating them as a collection of steps and not treating them for each step. Okay, let's try that. Yay! Yeah. Let's print this a bit nicer. Join. So part 1. And then we do I don't think that was that much nicer, but okay, part 1, blah. I don't think I need my nice set function either. And I think this can be done better. Oh well. Okay, let's do part 2. Okay, blah blah blah. With 5 workers and the 60-second step duration to describe how long will it take to complete all of the steps. Okay, so we're gonna do stuff in parallel now. Let's open up the Python 65. So subtract. Okay. Let's do that as a function. Time key or step. So I suppose we do this again. So we have we basically have the same thing as we did there. Clock 0. And I had a fixed number of workers right at 5. Four of the elves, yeah, so we have 5 workers. How do we represent them? Just do this. So this means that each worker 0 is available for work at that time, worker 1 is available for work at that time, and so on. Okay. And then let's just do... can we do index on that? Or find on that? I want all indexes when that matches. List. Index. Yeah, that's the first occurrence. I want all occurrences. List tuple list. Sort now. Let's just search Python list all indexes. Okay, so they do that thing. You enumerate it and then you get the list of the index of that. And then you keep that. Okay, fair enough. Let's just repeat this. Okay, so last thing we do is we step the clock, and then we need to keep track of, well, the clock is how long time it took. That's the last thing we do. Let's find the minimum value also. Yes. And then we do min. Okay, if then we clock is equals to delay. And then we go to the next. Check if workers are the same. If so. Right? If they're all working, then we can add the minimum delay, or I shouldn't call it delay. So they are available then. They are available later than the clock. So then we just set the clock to available, and then we need to subtract. No, we don't need to subtract because they have the time. Otherwise the time ticks. And then I need to do for worker and workers if. Can I do that? Can I do an if in a for? Is that even valid syntax now? Nah. If worker is bigger than clock, then next. Okay, so then otherwise we can actually do the work, which is basically what we did up here. I can suppose I can pretty much copy paste that. Or we can call this a let's just do the quick insert thing, copy paste it for now. And then we need to okay. And then the worker needs to be delayed by the value of the thing. So if I enumerate that, we get the index, the worker index, available. Oh, did I indent it one too many? Come on. Okay. Key frontier remove. And then so I'm not sure if this is a nice thing to do in Python, change the list, but I'm not changing the order or anything, so the clock plus the time of the key. Something like that. Does this compute? List item range sorted. Because I'm not doing that. I'm doing that up here, yeah. The workers can make the work available. We break out of the loop, and then basically have to that's the exactly, yeah, because they're not asking that. They are asking about the clock. 333. Did I get the time for the sample? 15. That's no good. No good at all. So available, that's the first time that the workers will be available. Then we just step the clock forward. Because there is no available workers. Otherwise, we go through and do work. For every work that is available. I wonder if this is off by 1 on that. Do I need to... So the clock is now that. If they start work on that, that will take extra time. What? In this example, it would take 15 seconds. How can it take 15 seconds if it takes at least 60 seconds to do any step? What? If it takes 60 fewer seconds. So let's tweak that. For the sample. Not so much, huh? No time is required between steps. Does it take that long to unlock it? Do I unlock it too soon? I think I unlock it too soon because I unlock it as soon as I touch it. I should probably unlock it at the end of the time. Okay. So I cannot add it. I cannot add it to the frontier yet. And I suppose working on Elnon. Can I do 0 times none? Is that Python? No. Suppose you can do 4 h5. So you cannot take anything that any worker is working on. And can I do 1, 2, minus 2? But they are sets already, right? Yeah, it's already a set. So I can do set of 1, 2, minus 2, minus a 2. Do I need to do a set of that as well? Yeah. So frontier, then I need to remove the set of working on. Key. Remove that. It's now available. Complete. Boop, doop, doo. Equals working on for BI. And then what? It's that part I can't do yet, right? So instead of doing that, so if working on, then union, right? That's updating. Yes. And then I'm working on jeez. Okay. So that would be the key they are working on. And I need that so no other elf start working on that particular key. And then when I'm done working, we should unlock the things that that key unlocked. So working on locks. Right? Working on locks, because this is the time to do completing work, working on blah blah blah, frontier update, working blah blah blah, working on locks. Sure. And then if there is nothing to do, we're done, blah 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 blah, working on, sure. Remove that key because we're not working on it. And I need to remember it. So working on is now key. And then that is the same as before, but instead of frontier, we add it to working on locks for the worker index. Traversed. And then this is sort of the order we did it. That doesn't really matter though. And then the workers will be working until that time. Okay, exit. Can I adjust my workers here for the example also? God damn, it's not working. Oh man. It's so messy. I'm a messy coder. I need to get good. That is the same as before. Let's do just print of a one. Right. Oh. I need to complete the work also. Can I just break instead? Like true. Do the work, add the stuff to the frontier. If there's no more work to be done, stop. I suppose they should all complete work. Complete work. So for worker index, so if available is talk next, otherwise we complete the work. otherwise we complete the work. Do more work. Okay. So, yes. Then we also, the working on is marked as traverse, right? But it's already equals on. And then down at this part is if all true for key in working on, if key none is none. So if it's true that all keys being worked on is none, then there obviously isn't anything to do. Advanced clock. Extend the frontier by the things it unlocked. Mark that it's not unlocking anything, it's not working on anything. Then do more work if the worker is available and there is anything to work on. So, okay. Get some work. And you get work from the frontier that nobody's actually working on. But we only add it to the frontier when it's, so we can remove that. Frontier, that's the work being available. Remove the key. Remember what key we are working on. Figure out what it unlocks. Add on to the step. Traversed. That seems that we'd be doing that. We'll be doing that up here. But and not down there. Worker will be busy with work until whatever time it is now, plus the time it takes to do the work. If all workers are available for work, that must mean that there is no work to be done. And we break. Otherwise, increment the clock. Do I even need to increment the clock? Isn't that handled by that one? Meh. What? Traversed. Is none. Is no. Working on is none. God damn. Okay, let's just see what it got then. None in 0 seconds with 2 work. Come on now, come on. I suppose I need to do. Advancing clock. Worker VI completed work on working on VI unlocking. Worker what? I need an F in there. Worker 0 completed work on none, unlocking nothing. How can I get what? Is equals what? Hello. So what does next do? Is it continue? Python language. Let's find loop. Loop. Quick search. Yes. So my next that I have some places should be continue. Break. Still not good though. Yes, so then a worker. No workers available. No, that's not true. Okay. Worker series now looking for work. Looks like we're all done. For key in working on. If key is none. So let's print that stuff here. We have the worker times, working on, we have working unlocks, we have clock. So worker time is busy until 3 o'clock, and he's working on C. That looks about right. Looks like we're all done. How do you figure that? For key in working on, if key. So let's just do key is none. Like that. Yeah. Okay. So they are working, but now time is not advancing. I did need to advance time. In 10 seconds. Work series looking for work. He will be busy until 3 o'clock. Might be a couple of off by one things. Okay, now worker series completed work on C, unlocking A and F. Yes. Worker 0 is now looking for work. Worker 1 is now looking for work. They both got work. They are now working on A and F. And he will be working until 4, unlocking B and D. That guy will be working until 9. Unlocking nothing. That's a problem. I guess I need to figure out that. Yeah. Yes. I don't know what it unlocks yet. And also you can unlock several things in the same. I guess I need to move that stuff out from here. So active workers are the for I enumerate. If time is less than or equal to clock. And then I can just iterate that instead. Strange. Find available workers. This would work. Complete the work they are doing. If they were actually doing anything. That is the thing I need to figure out. That I can do. That I can do. I need to figure out what it unlocks. And I suppose you added to traversed. So I think I need to do that in a two-step thing as well. So then we unlocked it. We don't need to unlock it again, but we did need to unlock it here because several workers can finish at the same time. And then I need to figure out what it unlocked. So unlocks is B for A and B in order if A equals And then we need to filter out the stuff that is still locked. Step and unlocks. Blocked. Maybe blocked. For yes. So find all the prerequisites for this one. And it is not. That is not the actual key we're working on. Can we just call this? Okay. We are blocked by A. A is not equal to the key. And the key that is needed is not in traversed. And then if not blocked, then we unblock it. Right? And the working unlocks is no longer a thing. Working unlocks. Do we have that anywhere else? That is actually a lot better. See, cab FDE instead of cab DFE. No workers available for work. Advancing clock. Okay, cool. This is quite messy. So yeah, we mark key as unlocked. Suppose I can just do check. Step and B. Can't I just do? I'll leave it be for now. Okay, 15 seconds, and then we tweak this back to that. We have 5 workers. We have input 1226. Yay, gold star. Okay. Load. Okay, not pretty, but I did like working with Python instead. This is the first time working on Python for a couple of years, I think. So I'm quite rusty. Kind of nicer than doing this in Golang that I did up until now. Or just Go, as it's called. I think I'll continue with Python. Possibly tweak this a bit. Polish this up a bit. Yeah, I think I will leave it at that. And see you guys tomorrow. Okay? Bye-bye!